all of you. So I hope you are doing well these days and watching those videos. So in the previous classes we have discussed about the oscillations and waves. Okay, so we have discussed so far about the transverse waves. Today we will start the longitudinal wave. I told you in the previous classes that the wave is of two kinds, that is longitudinal waves and transverse wave. We have discussed about the transverse wave. Now we will start our next topic, that is longitudinal wave. Okay, so let me start. So first of all, we have discussed that wave. Okay, it is of two types, that is transverse wave, and second one is longitudinal wave. Okay, so we have discussed that the transverse wave is the wave in which the displacement of the particle is perpendicular the propagation of the wave. Suppose in the transverse wave the wave is propagating in this direction and particle is displaced in the perpendicular direction from this. Okay, it may be in this direction, it may be in this direction. So the example of the transverse wave is an electromagnetic wave, like. Okay, so let me draw again this one. So this is the y and this is the time t, and at this position this is the x position. Okay, x1, it is x2, x3, like. So here the particle which is present at x1 position is displaced this much. Okay, particle at x2 position is displaced this much, and particle at present which is present at x3 is at the mean position. Okay, and at x4, this is say x4, and the particle is displaced in the negative direction. Okay, so this is the way, like the wave is propagating in this direction, that is plus x direction. Okay, but the displacement of particle is the perpendicular to the propagation of the wave. Okay, so this is the transverse wave. What about longitudinal wave? Longitudinal wave is the wave where the particles are displaced along the direction of the propagation, like wave is propagating in this direction, wave is propagating in this direction, and particles are displaced either this direction or this direction. It means that there is a parallel relation between the propagation and the displacement. Okay, so the examples of the longitudinal wave is the sound wave, acoustic waves. We will discuss this topic in our next classes. Okay, so here we can say acoustic wave as a pressure wave, both as a pressure wave. Okay, so let us suppose that I am speaking like this. Okay, and the pressure just in front of my mouth, the air is in front of my mouth is compressed. Like these are the air molecules. Okay, air particles, air molecules, water vapors, whatever it is present, whatever present in our atmosphere. Okay, so this is the compression, and then rarefaction, again compression, again rarefaction. Okay, so this is how the longitudinal wave is propagating in the air. So like this is the, let me write here, compression, this is rarefaction, again compression, again rarefaction. Okay, so or in other this is just in the air. Okay, like this we can produce a sound wave using tuning fork, है ना. Tuning fork we have discussed in 10th class I guess. Tuning fork, like it's just like a material this. ओके वो कुछ इस तरीके से हमें दिखता है और हम क्या करते हैं यहाँ पे उसको स्ट्राइक करते हैं, लाइक हम इसको किसी मेटल पीस से क्या करते हैं स्ट्राइक करते हैं इसको, तो यहाँ पे इस वाइब्रेशंस क्रिएट होते हैं. ओके, सो दीज वाइब्रेशन क्रिएट प्रेशर इन द एयर जस्ट प्रेजेंट हियर. ओके, सो व्हाट अबाउट द स्प्रिंग. ओके, तो स्प्रिंग, like a spring is like this and you pushed in this direction it. Okay, so what is the equation, like what it looks like then after the pressure. So like compression, then rarefaction. Okay, let me draw here. Okay, so this region is known as compression. This is the region of rarefaction, and this is again compression. Okay, so I hope it is clear that what is compression and the rarefaction. In the compression, the particle are come closer like this, it is so condensed then, and in rarefaction particles are quite far from them, far from each other like this. Okay, again compression, like it is so congested, no? Okay, and in rarefaction particles are quite far away from, they are not colliding, they are just at their positions. Okay, so this is the compression and this is the rarefaction. So I hope it is clear. Okay, so the wave equation, like we have studied in the transverse wave, the displacement of the particle is denoted by or expressed by this equation, that is y xt is equal to capital A sine omega t minus kx. Okay, if the initial phase phi is 0 here. Okay, if initial phase phi is present, then it will become a sine omega t minus kx plus phi. It may be plus, it may be minus. So this is the displacement of the particle. Okay, so similarly we can represent the longitudinal waves in this form also, but the here we can say similarly we can represent the longitudinal wave formula like this. Let me write. Longitudinal wave formula. Okay, like y xt a cos omega t minus omega x upon c. Okay, we can write that omega, we know that k times velocity is equal to omega. Okay, so omega upon c is equal to k, we have discussed now. So it will become y xt is equal to a, it may be a cos function, it may be a sine function, so this is omega t minus kx, or we can write also a cos omega we can take common t minus x upon c. Okay, so here y is the displacement of what? Displacement of the point on the traveling on the traveling sound wave. Okay, what about x? X is the distance of the point, distance of point traveled from the waves source, यानी कि जहाँ से हमारी जो वेव प्रोड्यूस हुई है, ठीक है, तो वहाँ से उसका डिस्टेंस कितना है। लाइक अगर आपकी प्रोपोगेशन इस तरीके से हो रही है वेव की, ठीक है, तो ये जो पोजीशंस हैं, ठीक है, मान लो ये आपका साउंड का जो सोर्स है, ठीक है, सो कोई स्पीकर है, ठीक है, तो कोई डीजे है, तो वो यहाँ पे आपका रख, तो ये इस साउंड से यहाँ से उसके पोजीशन क्या है, दैट इज़ दी एक्स, ठीक है। डिस्प्लेसमेंट कितना हो रहा है यहाँ पे, वो आपका हो जाएगा वाई, ये पोजीशन हो जाएगी एक्स, और जो किस टाइम पे हो रहा है दैट इज़ दी टाइम, ठीक है। सो टी इज़ द टाइम हियर एंड ए इज़ द एम्पलीट्यूड of the oscillations, okay, and c is the speed of wave, okay, and omega is the angular frequency of the wave. I hope it is clear that which terms is denoting the amplitude, which terms denote the angular frequency of the wave, which terms denote the speed of the wave. Okay, so here we can see that the quantity x upon c is equal to the time. Okay, in which time that wave takes to travel the distance x, यानी कि वेव को x डिस्टेंस ट्रेवल करने में कितना टाइम लग रहा है, दैट इज गिवन बाय x अपॉन c, ठीक है। तो फ्रीक्वेंसी ऑफ द वेव इज गिवन बाय, यू नो दैट वी हैव ओमेगा, okay, we have the angular frequency of the wave. So what about the frequency, है ना, linear frequency, we can say that the frequency f, or it is denoted also by nu. So nu is equal to 2 pi into omega, ठीक है। So I hope you have understood what is the longitudinal wave formula. Okay, so the wave equation, okay, so actually the longitudinal wave is the sound wave, acoustic waves are the example of longitudinal wave. So I will discuss the longitudinal wave equation in these two, na? It will repeat again, so that's why I'm not discussing here. So just it we have discussed so far that what is the longitudinal wave. So I hope it is clear that what is a longitudinal wave. I hope the basic concept of longitudinal wave is clear, is understood. So thank you so much